Alrighty, well, I'm back. In our last episode, we were working with these equations, right? And they're called linear equations, and you're going to find out in a minute why that is. But we said they had two variables in them, an x and a y, and we represent solutions to that equation, to those equations, as ordered pairs. And then we also discovered that unlike our usual equations that have one solution, these equations have literally millions of possible combinations, an infinite number. So how do we go about thinking about or organizing or representing in our heads all those possible solutions? Well, these ordered pairs give us a clue. So we're going to work with this equation here, and we're going to use this table here of values. Now, we're going to learn to call, and then hopefully I'm going to have a piece of the graph paper here. I don't know if you use graph paper to plot your points for the last homework, but for what's coming up, you're definitely going to need graph paper. And if you don't have any at home, you can at least hopefully be able to print out the plain graph paper here that I posted on Canvas. Anyway, so here it is. So what we're going to do is we're going to plot these points here that we found for x plus y is equal to 3. I'm going to write it here. I'm going to make, okay, cool. I'll use this one. Okay, so here is, hopefully you can see this, x plus y is equal to 3, right? And then we had this table here. I'm just going to write the x and the y values. I'm not going to bother with the 3 column because we know what they're all supposed to add up to. Okay, and these were ordered pairs, some of them, that made the equation true, right? So let's go ahead and on here, let's plot those points. Okay? Okay, so this is going to be, remember, this is the x and this is the y. And so this will be the horizontal left-right move, and the y number will be the vertical, the up, the down move, right? So if I want to plot 1, 2, that means I always start at 0, 0. I'm going to go right 1, up 2. And these are numbered 1. So this is 1, 2, 3, 4, 5, positive 1, positive 2, positive 3, positive 4, positive 5. This is negative over here, negative 1, negative 2, negative 3, right, and so on. And this is positive for the x and negative for the x, positive for the y, negative for the y, down like this, right? So, and then we plot 2, 1. That's the x is 2, the y is 1, so that's over 2, up 1. That's right here, right? 3, 0 is right 3 in the x direction. The y is 0, so we don't go up and down at all. So that just sits on the x-axis. And then, oops, I skipped over. That's 3, 0, 0, 3. That's 0 in the x direction, so we don't go horizontally at all. We just go up 3 and 3 in the y. Right? Now we can even check some of the other points that we plotted. For example, we had negative 1, 4 and negative 2, 5, right? Like that. So to plot negative 1, 4 would be 1 to the left and up 1, 2, 3, 4. Because remember, always do the horizontal first. And then negative 2, 5, 2 to the left, 1, 2, 3, 4, 5. Right? That's how that works. And any other combination of numbers here. Now, what do you notice about those points that we just plotted? Okay? You notice that they all line up on a nice straight line. So this equation is called a linear equation because when you plot ordered pairs, that are solutions to that equation, they fall on a nice straight line. So that means all the ordered pairs, every single one that makes this equation true, will be somewhere on this line. And I'm going to use my ruler. I'm going to draw the straight line through. I'm going to put arrows on the end to show that that's a line and it can just keep going. Okay? Now, the thing is that that line now represents all the ordered pairs that make the equation true. And a line is made up of an infinite number of points, so all the solutions are there. So, for instance, let's check this out here. How about that spot right there, which is on the line? Well, what is its ordered pair? Well, it's 1, 2, 3, 4, 5. And then, so its x number is 5, right? Can you guys see that? 5, all right? And its y number, it goes down 2, so 1, 2, so its y number is negative 2, right? So now, if you plug 5 in for x and negative 2 in for that equation, you should see 5 plus negative 2. Yeah, that's the same thing as 5 minus 2. That comes out to be 3. Right? That's how that works. Or how about that one up there? That's 1, 2, 3, 4 in the left direction. So that's the ordered pair negative 4, and then 1, 2, 3, 4, 5, 6, 7. So that's the ordered pair negative 4, 7. Oh, look, negative 4 plus 7, is that equal to 3? Yes, it is, because that's the same thing as 7 minus 4, which gives us 3. Now, what about a number? What about this point right here, which is clearly not on the line? Well, that's over 1. Its coordinates are 1 to the right, 1, 2, 3, 4, 5, 6. That's the ordered pair 1, comma 6. And you can see that if we substitute 1 in for x, 6 in for y, 1 plus 6 not equal to 3. So that's not a solution. So the points that are on this line form an exclusive club. They're the club of all points that make that equation true. You're either in the club or you're not in the club. You're either a solution to this equation or you're not a solution to the equation. If you're anywhere on this line, you make the equation true. You're a solution to the equation, so your ordered pairs, whatever they are, will make that equation true. If you're somewhere else, anywhere else, whatever your ordered pairs are, they won't make that equation true. So that's Descartes' kind of creation or invention or discovery, however you want to think about it, the idea that a simple shape, like a straight line, can be represented by ordered pairs. And it turns out to be highly useful. For example, in computer animation. Because these could be the points that make up a line that you see drawn on the computer monitor in front of you. Okay? All right, so that's kind of how that works. This is a linear equation. Now here's a tip. So here's what you're going to do. I'm going to give you some ordered pairs, right? And we've graphed those already, but I'm going to give you an equation. And I'm going to say graph that equation. It's going to be a linear equation, okay? And so that you'll calculate some points for it using this table here, you'll graph those points. If it's a linear equation, the point should come out onto a straight line. Okay, so I'm going to put this one here, this one away. So this is going to be our instruction, you understand, ladies and gentlemen. You're going to be graphing a linear equation. And how do you do that? Well, there are steps. Okay? So let's say, so here's what we're doing. We are graphing a linear equation. Now, one of the key things about this is I'm going to be able to put more than one line on here. Okay, hopefully that won't get too confusing. I'll use different colors. Okay, so let's say we've got the equation. Here's going to be example 1. It'll be x plus y is equal to 6. Okay, that's going to be our first one. Whenever we, the graphing a linear equation for us is going to have 2 steps, basically. Number 1, or step A, you're going to make a t-table, and you're going to write down 3, at least 3 ordered pairs that make that pairs of numbers that make that equation true in either order. So x plus y is equal to 6. So we can see that, for example, hopefully you can see it here, 6, 0, because 6 plus 0 would give you 6. It could be 0, 6, right? Because 0 plus 6 would give you 6. It could be 1, 5, because 1 plus 5 would give you 6. It turns out we only need 3. But in order to graph a linear equation, you have to have at least 3 ordered pairs. So now what we do is we graph those 3 ordered pairs on our xy plane. Remember, here's the y, and this is the x, and each of these boxes are numbered by 1s. This is the positive x number line, the negative x part of the number line, the positive y part of that y number line, the negative y. So to do 6, 0, I'm going to count 1, 2, 3, 4, 5, 6 right there. Right? 0, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 right there. 1, 5. Over 1, 1, 2, 3, 4, 5 right there. Now here's the thing. If we do this right, if you calculated your 3 points correctly, why they will fall on a nice straight line, and we don't need to do anything else except take up my ruler, use a ruler, that line represents all the other ordered pairs, and we don't have to calculate anymore. So for instance, this one right here, you can see that one is, this point here is over 4 up 2. So that's the ordered pair of 4, 2. And oh look, 4 plus 2 gives you 6. Okay? So that's how that goes with graphing linear equations. Okay? And the way we're going to do it, step A is going to be make the t-chart with 3 pairs of numbers that make the equation true. And then B, graph the points, or plot the points on the graph. And then C, draw a line through the points. Make sure it goes all the way through. Put an arrow on the end to show that the numbers, that line, and the ordered pairs that are on that line can just keep going. Big as we want or as small as we want. Okay, so that's how that works. Okay, so here's another one here. Let's do another example. I'll use a different color here. Number 2. Okay, how about 2x plus y is equal to 8. Now what you've got to do is, I'm trying to make these not too difficult to work out in your head. I'm going to write these out in a slightly different format for the third one. Can you see here that 0, 8, 4, 0, and 1, 6 will make these true. Because 2 times 0 is 0, plus 8 is equal to 8. 2 times 4 is 8, plus 0 is equal to 8. 2 times 1 is 2, plus 6 is equal to 8. So those all make the ordered pairs. That makes the equation true. So 0, 8, 1, 2, 3, 4, 5, 6, 7, 8 that's up here. 4, 0, that's here. 1, 1, 2, 3, 4, 5, 6. And if I figured it correctly, those should all fall onto a nice straight line. Oh, goody, they do. So I draw the line through just like that. Now, a lot of times, it's more convenient, and on your homework, I might put them like this. I'm going to use another piece of graph paper here. So this is so that's easier for you to see, so that's a little less busy. Okay? I'm going to write the equation like this. Here's example 3. Y is equal to 2 times x plus 1. Now, that's actually an easier way to write it, because I don't have to do ordered pairs in my head. All I have to do is pick 3 numbers for x. And 0, 1, and 2 are convenient choices. And I use the equation instead of having to do it in my head like we did on the last ones. I can just pick these x numbers, put them in for x, and calculate what the corresponding y number would be. Okay, I meant to make this another color, so let's let this one be light blue. Okay, 2 times 0 plus 1, that's equal to 1. 2 times 1 plus 1, that's equal to 3. 2 times 2 plus 1, that's equal to 5. Do you see what I did? I picked 3 x numbers, 3 easy ones, and I plunked them into this little expression here, and that tells us for each x what's the y. So I'm going to graph these ordered pairs. 0, 1, 1, 3, 2, 5. 0, 1 is right there. Over 1 up 3 is right there. Over 2 up 5 is right there. Okay? 1, 2, 1, 2, 3, 4, 5. And you see they come out on a nice straight line. And I carefully draw in the line to represent all the other ordered pairs. Okay? Kind of like that. And that line represents not only the 3 ordered pairs that we already calculated, but literally all the other ones that we could calculate from y equals 2x plus 1. Okay, so let's try green here. Number 4. Okay, how about y is equal to 2x minus 1? Okay, we're going to make our t-chart here, x and y, where the y number is equal to 2 times whatever the x number is, minus 1. I'm going to pick my easy 0, 1, and 2 numbers again. I'm going to plunk them into the equation to calculate what the y number should be. So the y number is equal to 2 times 0 minus 1. 2 times 0 is 0. Minus 1 is negative 1. Here, the y number is 2 times 1 minus 1. 2 times 1 is 2 minus 1 is 1. And in here the y number is 2 times 3. Sorry, 2 times 2 minus 1. 2 times 2 is 4 minus 1 is 3. So that gives us, I hope you can see the ordered pairs 0, negative 1, 1, comma 1, 2, comma 3. There's the x, there's the corresponding y calculated from the equation, right? So I'm going to put that in. Okay, in green, 0, negative 1 is 0 in the x. Remember, there's the y and there's the x. Okay, 0, 1 is 1 down on the x-axis, over 1, up 1 for that one, and then over 2, up 3. And there it is. There's the equation. Okay? Now, I'm going to put some of these on our homework, on the classwork for you to try out. Okay? And I'm going to have some classwork for you to work on and some homework. And then come, let's see, Tuesday, I guess it'll be, we'll meet back in a video conference. And I'll explain to you a little bit about more details about how the final is going to work. Hopefully you saw the announcement I sent out about it, but there's going to be more detail, and I'll tell you exactly what you need to do about the final. But I also want to talk about this too, because this is a big and a very important piece to be able to understand for algebra. Okay? Bye.